Good morning. My name is Isabel Hernandez. I want to thank UC Cooperative Extension for inviting me to be part of this meeting. Unfortunately, I cannot be with you today, but I will be happy to answer any questions, so feel free to email me. Today I'm going to talk about blueberry production in California and some of the experiences I've had during the past 4 years with research about blueberry production in UC Davis. But I would like to start by talking about blueberry production around the world. It's been produced in all continents, with the majority in North America, and the consumption of the fruit has been increasing for the past 10 years. And this is related to the nutritional and medicinal characteristics that the fruit has, related to the high content of anthocyanins. In the United States, California occupies position number 7 in area harvested. You can see here the states that are the main producers of blueberry. But what makes important the fruit produced in the state of California is that it can supply the demand on May, which is the off-season. So it's the first fruit that comes at the beginning of the harvest season. Yield in California, it's around 9,000 pounds per acre, and also it occupies first position in terms of price per pound of the fruit produced in the state. There is blueberry production around all California, but here are the main counties with acreage on blueberry production. Now, what's the main constraint for blueberry production in the state of California? And the main problem for us is the high pH soils that we have in the state. See here in the map, on red are those areas with a soil pH greater than 7, and this impacts blueberry production just because these plants require acidic soils for our optimum growth. Then, in order to grow healthy plants, we have to have in mind two main aspects. The first one is to be in the optimum pH range that goes from 4.5 to 5.5, and also we have to provide nitrogen as ammonium, since these plants are not able to take up nitrate as a source of nitrogen. So when we are growing these plants in high pH soils, it's very common to find deficiencies in nitrogen, since nitrate is the most abundant source in those soils. And also, as you can see in the picture, there are some deficiencies related to unavailability of iron and manganese that are related to intervenial chlorosis in new leaves. Intervenial chlorosis means green veins and yellow leaves. Now that we understand the needs that these plants have to grow healthy, it is important to test the soil before planting, to test how the pH is, the condition of the soil, and to acidify soils if necessary. It's also important to test the water, to apply in the range of 5, pH 5, to have healthy plants. And also we have to add organic matter at the beginning of before planting, but also reapply every 2 to 3 years to keep moisture in the soil. But then the last thing that is important to have in mind is to have good drainage. These plants do not support flooded soils, so it is important to have these 4 things in mind. What we usually do in California when we have a neutral to alkaline pH soils, what we do is to apply from 3 to 5 tons per acre of sulfuric acid. It is important to apply the acid at least 6 months before planting, and for the process to be successful, it is necessary to apply abundant water, a flooded area, just to make the process go faster. There is an option if we want to grow organic blueberries and we need to acidify soils. It's accepted to apply elemental sulfur. However, it takes longer and you have to be extra careful to be successful on this. The organic matter that is usually applied, it's pine bark, mostly in sandy soils, and as I mentioned, it goes from 2 to 3 years that have to be reapplied. Then before planting, being applied the mulch or the organic matter. So what we do before planting is to have raised beds and flat rows that it's improving drainage, as I mentioned, and then installing the irrigation system. After having the soils ready for planting, we have to select the variety that we want to grow. So the commercial blueberry come from 3 types of blueberries. We have the high bush blueberry that are divided in northern high bush blueberry and southern high bush blueberry. Those are shrubs that are most of the commercial varieties that we know. The northern high bush blueberry is mainly produced in Oregon, Washington, and northern states. But for California and Florida, it's the southern high bush blueberry, the ones that are preferred. Low bush are those small shrubs that grow mostly in Canada and Maine. And rabbit eye are most rustic types of blueberry that are grown also in the south. What makes the difference between these types of blueberry is the chilling requirement, and we have to have that in mind. Chilling requirement means the number of hours from a temperature from 32 to 45 Fahrenheit degrees. So for our state, it is important to have varieties with a chilling requirement not higher than 200 hours. The cultivars that are mainly produced in California are Jewel, Emerald, Star, South Moon, O'Neill, Snow Chaser, and there are some others that have been evaluated in terms of flavor, texture, and something that is important from them is that they are produced by the end of May, beginning of June. Those factors to consider when we are selecting our cultivars are, after, of course, knowing what is the chilling requirement, we need to have a target depending on the timing. If we want to impact the market early in the season or late in the season, it's variable depending on the cultivar. Also, we have to understand post-harvest that it's mostly related to firmness, sugars, and weight. On this table, you can see the evaluation that we did during the season 2016 in Kearney, where there is a trial with all of these varieties that you can see here. And on red, there are those that were harvested early in the season, mid-season, and in blue are those that were harvested in late season. There are also some of them that are not competitive, depending on the type of fruit, the sugars, and etc. Irrigation in blueberries usually done by drip irrigation with emitters of 8 liters per hour in those sandy soils, and the amount of water to be applied is related to evapotranspiration that it is found in the CIMIS webpage. This is very, very useful information that we can use in terms of applying the requirements exact that they have. Just an example, for those plants that I had in Davis during the summer season, the irrigation with having 2 drippers per plant was around 17 minutes per day, distributed in each 6 hours, just because they were planted in sandy soils. So it is required to have good amount of water, but also distributed along the year to avoid leaching. Fertigation is also common in blueberry production, but for this we have to have in mind the critical levels for soil nutrient content for blueberry production. According to Strick, these are the values that we have to target, and if they are not present in soils, that we are going to know already when we have the soil test for soil preparation. So we have to add to have at least this concentration of nutrients in soil for a healthy production. Pruning. It's special in California. Is different from the practice that has been done in Oregon, Washington, and other states in the north. As you can see in the picture, pruning occurs right after harvest. This is during summer, and what is being done, it's cut in the top of the tree about 36 to 48 inches with an angle. Usually when we do this during summer, the shoots are gonna have or gonna develop the flowers ready for spring. Now that we talk about generalities about management of blueberry plants, I would like to share with you some of the results from the research that has been done in UC Davis for the last 4 years. These are 2 methods for blueberry production that do not require soil acidification. So the first one was a grafting experiment. The grafting was performed in a pot-in-pot system, which means 2 pots that are buried in the soil. Then we can have some flexibility of those plants if we want to mobilize them, to have them indoors or etc. These pots had a capacity of 15 gallons and they were filled with sand, peat, and bark. Grafting has been used usually to change the morphology of the tree or the shrub. As you can see on your left, there is a grafted plant that has a single trunk, compared to a non-grafted blueberry on your right that has a multi-trunk, which makes a single trunk important. It's that it makes mechanical harvesting more efficient. So this is the main reason mechanical grafting has been made, just to improve mechanical harvesting. But for the soil conditions of California, there is also important to have the use of rootstocks when they are more tolerant to high pH, and this is the thing we evaluated, how the tolerance to high pH soils was improved by the use of a rootstock. The rootstock that has been used for blueberry production is called sparkleberry. It grows widely in the east coast of the United States. It tolerates high pH soils and has a deeper root system, also has an erect and single trunk that favors mechanical harvesting, but their fruits are not suitable for market just because they are smaller fruits, they are bitter, and they have a high concentration of seeds. Blueberry instead has a better fruit quality, but it has a multi-trunk that it's not very good for a mechanical harvesting. And also it has a shallow root system that goes from 15 to 36 centimeters. For grafting, it is important that the scion, which is blueberry, and the rootstock, which is sparkleberry, they must have a diameter of a pencil. Also, the rootstock is planted during the fall, and the scions are collected during the winter when they are dormant. As you can see above the clippers, they are the floral buds that they have to be removed when we want to graft. We don't want to keep flowers, but the vegetative buds that are below the clipper, those are the ones that have to be grafted. The method for grafting blueberries is the method of whip and tongue, which means two cuts, one that is diagonal, the first one, and it's similar in the rootstock and in the scion. Here in the picture on your left is the cut that we make in the rootstock, and in your right the cut that we make in the scion. It fits perfectly. Then it has to be done in a short period of time, and then it has to be covered by parafilm and tied with a rubber band in order to keep both tissues together and to avoid desiccation. This is right after covering with the parafilm. We can see in the top there is the blueberry scion, and in the bottom there is the sparkleberry seedling that is already planted in the pot. They are exactly the same diameter, and then they are covered, as you can see on your right, not only the place where the union is, but also we cover the whole scion to, as I mentioned, to avoid desiccation. And 3 weeks after, the vegetative buds on the scion start pushing the parafilm and grow. It occurs around 3 weeks after the moment of grafting, which is around end of April. It is important to keep irrigation and to remove any buds from the rootstock, just because we don't want competition between them and we want the scion to be strong. During the first year, from April to next spring, which is the second year, we shouldn't leave those any flower to develop or any fruit, but for second year, first harvest occurs. In our experiment in California, we haven't found any clear results yet, but we only have grafted plants for 2 years, so we have to wait a little bit longer. Here on this slide there is a picture from an experiment performed in Florida from Dr. Darnell. As you can see, there are 2 shrubs on your left that are grafted onto sparkleberry in a high pH soil, and on your right there are 2 shrubs that they were non-grafted in the same conditions of soil. The comparison is clear. The grafted plants could grow faster, better, and have greener leaves that are going to be reflected on bigger fruits and better quality of fruits. So as I mentioned, from certain cultivars, the results are clear, faster than others, but also we have to keep working on this to have results from the cultivars we use in California to start this practice, to develop this practice widely. As a conclusion, the potting pot system can be used for grafted plants or for ungrafted ones, and usually it's been done with buried pots, double pots that are buried in the soil with a capacity of 15 gallons. The advantages of the pot input system are that there is no soil acidification required, since we are going to apply our own substrate that I'm going to talk later. The second one is that there's no weed competition, since these roots are separated from the rest of the weeds that can grow in the soil, so there is no nutrient competition. And the third one is flexibility, since we can move this crop in case of it is needed, even indoors or etc. The substrate that you use for the pot input system, it's a mix of Canadian peat moss, blade sand, and pine bark in a ratio of 1 to 4 to 2 that is prepared before putting in the pots. And then what is very important here, it's the irrigation system that it's been used to apply the nutrients. The amount of water is similar to the irrigation we make in the field, but since we have sand on these pots, it is required to split irrigation in the day, since it can be evaporated sooner. This is just to show you the pot input system that it was planted on November 2016 at Veg Crops at UC Davis. The plants that were used were Cultivar Jewel from Fall Creek, and they were performing really good from the time of the experiment. That's, as I mentioned, it's been only 2 years. This is the solution we created and evaluated on the pot input system with very good results. What I want to point out from here is that the source of nitrogen was mostly ammonium, because it keeps an acidic pH on the solution. But also we applied some source of nitrate just to apply calcium to the solution, and also to keep the balance on charge. The source of the micronutrients, iron, zinc, copper, and manganese, were applied through a chelated form that also showed good results. Then we didn't see any symptoms of deficiency on those plants grown in the pot input system with this solution. Here we have a 1-year-old plant, well formed, growing healthy, only vegetative growth, and ready for next year for first harvest. Later we had 2-year-old plants ready for harvest with a better canopy formed, with a higher leaf area formed, and as you can see, the first clusters of fruits are formed and developed for first harvest around May. Finally, I would like to acknowledge those organizations and people that made this research possible. So special thanks to CDFA, Oregon State University, and University of Florida, and to you for attending this presentation. I hope you enjoyed the presentation, and also I will be happy to answer any questions or comments or anything you might have. My email address is isahernandez@ucdavis.edu. Thank you so much.